Yeah, so really excited to be here today. In fact, I guess this is kind of a challenging thing as well. Usually doing the talk right after lunch because I guess most of you will be in kind of like a food coma right now. But don't worry, we'll try and make things fun. As you can see over here, going wild with Google Cloud. What the heck? How can you go wild with Google Cloud? Let's see. I'm going to be sharing with you some of these case studies I've been working on over the last year within using Google Cloud itself, and sharing with you how you can use Google Cloud in building solutions for your own problems. All right, let's start. Okay, so very quick self-introduction. My name is Weiyuan, and I'm a Google developer expert in Google Cloud. Okay, and yeah, so essentially, this is within the area where I just usually build my own, fun side projects within Google Cloud, and I usually share it with the communities. I'm also in my day job, I'm an engineering manager at Grab. So, if you have questions regarding that later on, you can also ask me. Okay, so before we go into the main topic, on what solutions I've built or what tools I've used to build for my projects in Google Cloud, I want to talk a little bit about the life we had before cloud was a thing, so that we have some level of appreciation on the tools that has been created for us in Google Cloud. Okay, so some of you might remember this situation before there was the cloud. In certain companies, you have this room where there's this AC running 24 hours, all your server racks inside, the hardware. This is all your company running its own applications, within your own web servers or your hardware servers here. Accompanying that, okay, this situation does happen. I mean, well, we don't really want it to happen, but it kind of describes what this situation is, which is that the running of your own hardware itself is not really a deterministic thing. Certain failures can occur. Let's say if you plug the wire incorrectly, or like hardware can deteriorate over time. So sometimes when we deploy something new, we literally pray like that things go well. We don't want things to fail. Okay. And with the inauguration of cloud, life is really good. The cloud providers have taken care of most of these hardware concerns, infrastructure concerns for all of us. We're just taking care of the using of their product. And we also leverage on top of benefits like economies of scale, because for these big providers like Google Cloud, they can, purchase these huge amounts of machines, house it in their own data center, get that level of economies of scale, while we just use a part of those machines that they cover for in their data centers. Okay, and this is just to demonstrate the extent of services that's provided by Google Cloud today. Not just for simply hosting your applications, like in the past where if you have your companies having its own server rooms. We're now looking at cloud providers as a service provider, more than just those hardwares, but rather provision of many different services. You can see over there, of course, it's a little bit small, but because there's really so many things that's provided for by Google Cloud. Like, for example, you can see over there, there's IoT, there's like Firebase, Workspace, database, many different purpose that things that you need to solve for building an application. You can use Google Cloud, find a managed tool that they already solved that problem for. Don't have to reinvent the wheel. Just use that to build your solution. Okay, so with that, I'm going to bring you into two case studies I've worked on over the last year. One complicated example and one more casual one that you can probably use as a base for building your own solutions for your own projects. Okay, so we'll start with the complicated one, which I call it, I name it as live streaming with Google Cloud. Okay, so here's the problem statement. All right, so as you all know, over the last few years, there's this global pandemic event that went on within the years of 2020 or 2021, in fact, even this year. But of course, now we have physical events, which sort of departed away from the need to have to bring our events online. But the problem back then was that I was leading a online community where we have to do some of these events, inviting speakers and getting them to talk to our audiences. So we know that we couldn't do physical events then, but we have to bring this online. So some sort of live streaming solution. But there were three things that we needed to solve using this live streaming solution. Okay, firstly, easy to use. Easy to use means that any guest speaker that comes in shouldn't have to go through a 1 hour onboarding session. They should be able to onboard within like 5 minutes before the entire presentation starts. Okay, then they can just share their materials with the audience right away. And then the other thing is also affordable. Okay, because I was running a not-for-profit organization, we don't really want to spend too much money on any solutions. And lastly, we have a special condition we want to solve with our solution, live streaming solution over here, which is that we were working with multiple partners where we wanted to stream, send our live stream to their YouTube pages or their Facebook pages. So essentially, we could be streaming to like 5 different destinations at one point. Imagine like 5 YouTube channels together in one single live stream. Okay, so we needed a live streaming solution that could solve for all 3 of this. And we did try to investigate around, as engineers, there's this intro adage that mentions, don't reinvent the wheel. If it's already out there, just go and use it. It's probably cheaper. But the thing is that we really went to look around. We tried, free solutions like, through Facebook or YouTube directly, or we even use like open source solutions like OBS, and even things like, commercial solutions like StreamYard, which actually they are using right now. And what we found was that not any of these solutions solve for all of the qualities that we wanted. Okay, so we realized that there wasn't really a solution out there that helps us get to the live streaming solution that we need. Okay, so that's why I was thinking, I'm a GD in Google Cloud. Why not I just build something around this and make it better? Maybe, one of the solutions that I just introduced, I could just improve them and allow me to get the final solution that I need. Okay, and that's exactly what we did, which was to build a wrapping solution in Google Cloud around StreamYard. Okay, so you can see over there, this is essentially how StreamYard works. StreamYard itself is a very easy to use streaming tool. So any guest that we bring into our events, they can onboard really, really quickly. Okay, and the problem there is that there are many different subscription tiers for StreamYard. Okay, if you want to stream to more channels, you need to get to a higher subscription tier, which is not affordable, more costly for us. But what we decided to do around this is, what if I send my stream from StreamYard over to one of my applications in Google Cloud, and then use that stream to multiplex to multiple destinations, as many as I want. Okay, and I'll only host this solution when I'm running this live stream, allowing myself to minimize the cost as much as possible. Okay, if I'm not running any live streams, which is most of the time, I can just turn off most of my machines and not pay the money for them. Okay, so this essentially, on paper, we knew that it could solve for all of our needs. Okay, talk is cheap. Let's talk about how exactly did we solve for this. Okay, so we start off with a very high-level diagram. We knew that there's some sort of black box over there, some solution we need to build and host in Google Cloud, and use that to stream, pass the stream from StreamYard to multiple destinations. Okay, so AKA this is that black box. But we knew that, okay, because we need some sort of web application to relay that stream from StreamYard to our destinations, it need to be some form of multiplexing application over there. And if this is some sort of web application, I think it goes without saying that we can just start looking towards those hosting tools in Google Cloud first and find out what we can use to solve for our problem. Okay, and like I showed you just now, that big chart, or rather that chart with a lot of tiny words, right? There's so many solutions. Indeed, there's many different choices that you can choose from, for your hosting problems. For example, you can see over there, I gave 2 examples. One serverless, which is easy to scale, easy to maintain. Then there's also other options like infrastructure as a service, which is easier to customize, okay, which is you getting your own virtual machine and maintaining it yourself. Okay, but of course, as I also written over there are trade-offs. Any solution you use, if let's say you're going with serverless, that means you leave the responsibility for managing the lower levels of infrastructure to Google Cloud. Okay, so you let them do most of these things. It means that you don't have control over customizability at the granular level. But if you need that option, then maybe you need to do it yourself by running the virtual machines yourself, for example. But this means that you can't leverage on the additional tooling that Google Cloud builds in, for serverless. So again, trade-off, find the right tool that you need to solve for your problem. Okay, and for us, it was actually a very simple choice. For live streaming, there's this thing called RTMP, and it's not supported in serverless today. So very simplistic. We just need to get, we know that we need to go for compute engine, which is to get our own virtual machines. At this point, I want to highlight, if you all take a look at the lower left-hand side of the slide itself, I'm going to start adding in icons as well to indicate the tools I'm going to be using in this entire solution. Okay, just to show you, the complexity of these solutions, but how elegantly they can all fit in together, at once. Okay, so you can see over there, we've added in one new tool, which is Compute Engine. We've replaced our black box, our initial black box, with a virtual machine instance. Okay, just to describe a little bit about the web application running in this virtual machine. Okay, so it's basically running a Nginx server with a customized RTMP module. It doesn't mean anything, like I'm just saying all the acronyms, it doesn't mean much here. But I'll describe it like this is basically like part of the code running in there. Energis is basically just taking the stream from StreamYard and then forwarding to multiple of those destinations. Okay, so I'm not going to jump into this. If you're curious, you can ask me more about this RTMP module later. But I think the more interesting part is how we actually built this entire solution in Google Cloud. Okay, there's also some other things I added in this virtual machine, like Astana and Node. But again, additional details. I'll actually talk about the Node backend later on. It's actually a very interesting portion that we use to build a different part of this solution. Okay, so with that, we have our basic virtual machine instance in with some web application running there. Okay, is this complete? We can do more here, right? What about network configurations? If you are thinking about making your application scalable, you're running your own compute engine virtual machine instances, maybe you need to think about networking configurations like setting up your own load balancers. And let's say there are also more configurations I can set on top of this virtual machine in its own VPC or virtual private cloud, to make it more secure. So I can add in something simple as just only exposing the port 1935 on a firewall, because that's what RTMP runs on. I don't need to expose any of my other ports unnecessarily. Okay, so just one small improvement over there. What else can we improve here? Some of you might be asking, wow, you want me to run a virtual machine? That means I need to shell into the virtual machine. It's like running your own laptop, right? Then you need to go in and type apt-get install nginx, apt-get install Astana, then you can run it. And well, we have more choices than that. We don't need to manually do it ourselves if you're running in Google Cloud, even if you're using virtual machine. Okay, I've mentioned this. Some of you who are more perceptive, or if you've used Google Cloud before, you might know that you have serverless solutions that already run on containers, or Docker images that you create. You can also do that for virtual machines as well in Compute Engine. Okay, so you can use this thing in the middle of the screen. You can see over there, Container Optimized OS. Okay, so you can use the Container Optimized OS configuration for Compute Engine to allow you to run a Docker image at the moment the entire virtual machine is started up. Okay, so what this means is that I can essentially, okay, it's a little bit small, I'm sorry. But yeah, on the left side of the screen over there, you can see a Docker file. Essentially, you can use that to build a Docker image. And within this Docker file, you will see certain instructions like, okay, one instruction for installing Nginx, one instruction for pulling in the configuration for my Nginx server, just now the README, the file that you saw earlier on. I'll back up all of this and build it inside one image, okay? And at the point of me deploying this application to a virtual machine, they'll just take this entire image and bring up that container, okay? So what that means is that I don't need to go and personally shell into that virtual machine and type in all those commands myself, because it's already all done. It's already all configured as part of that image. And you can see also on the right side of that screen, it will indicate to you the virtual machine's configuration for that image that you use. Okay, so over there, they will show you that there is a container image being used with some address over there. Okay, and at this point, some of you might be asking, oh, I must be hosting this image somewhere, right? This container image. Is it hosted in a public domain? Like if I use something free like Docker Hub, if you're on a free subscription or the free account, essentially all your images must be in the public domain. You can't set the visibility as private. But can we solve that? Can we solve for this hosting image solution within Google Cloud itself? Okay, it turns out you can by using something else called the container registry. Okay, so there's actually two solutions you can use in Google Cloud for hosting your own Docker images. One of it being container registry. Okay, you can see over there on the screen itself, you can upload as many versions as you want on the left-hand side. And on the right hand side, the web console actually shows you that the image itself for the repository, you can set the visibility to private. Okay, you can also set it to public if you want. If for some reason you want to actually expose it for other people to use, or maybe let's say it's part of some open source project. Okay, with that, we've managed to circumvent around the entire manual process of setting up our virtual machine. But some of you might again be asking a question. Well, there was that Docker file, right? Does it mean I need to run that like build command locally on my device and then push the image upwards? Wouldn't that introduce more problems? Like, let's say if I'm in a team of like 5 to 10 developers, some developers maybe newer to the team, they may not know there are certain complexities to this application. Maybe some of them will actually build with the wrong code, they upload it, and then somehow your entire project disappears. I have had that happen to me before. Someone building that image locally on their device, deploy it, and then we end up with a completely different website. So it was a little bit embarrassing in terms of like that failure when it occurred. And we knew that we need to find some sort of a common environment where everybody can trigger this building of this image without having to get them to do it locally on their own machines, to introduce all this human error. Okay, so some of you might be very familiar with this term CI/CD pipeline. Okay, so can we build a CI/CD pipeline with Google Cloud? You can do that by using this very nifty tool called Cloud Build. Okay, so again, another tool we have introduced into our solution over here. On the left-hand side, that's a YAML configuration. So when you are running Cloud Build, you can create your own YAML file configuration for describing what you want to run during this CI/CD pipeline. In this case, this configuration over here is just very simply describing the first step as installing some node modules and then baking it into a Docker image. Okay, so it's just very simply building an image for a node application. But you can have more complicated CI/CD pipelines. Like for example, for a Rails application, where you have a front end and back end components, you could essentially write your unit test for front end and back end as well, right? And you can change this pipeline to run in parallel, to run both the front end and back end unit tests at the same time, allowing you to complete that run of that CI/CD pipeline a lot more quickly. Okay, so there are different ways you can use this CI/CD pipeline to match for your own building needs. And on the right side, the web console is just showing you, once the entire pipeline has been successfully completed, you just get all green check marks. If something fails, they'll actually let you know as well. There'll be some red cross marks. And then you can read the logs, okay, the precise logs of what happens in those stages, allowing you to debug very, very easily from your CI/CD pipeline. So it's not something that's not visible to you at all, but rather something that's very much allowing you to expose yourself to, what goes on in your entire build pipeline. Okay, so with that, we've managed to automate the process of allowing ourselves to build our image and then allowing us to take that image and deploy on top of our virtual machine. How can we make this application better? By looking at it even more, I realized that looking at this application, how do I secure the stream from going from StreamYard over to our virtual machine? Like if I don't secure the access, right, does it mean that anyone with a RTMP stream, like let's say through StreamYard or Google Meet, can just hijack it, like send that stream over to my server, and then allowing, like hijacking my stream, showing something completely inappropriate or different? And we want to prevent something like that. So we already have certain credentials built in into our virtual machine, the application itself. But then this credentials means that there's some form of secrets that we are hosting within our virtual machine. So there are a few ways you can add your secrets. I think some of you might be familiar with the term .env file or env.json file. Of course, you can manually shell into the virtual machine and put it in, input yourself. But again, we want to go away from that manual process, because that would mean that every time someone redeploy this application, you need to go in and redo this process all over again. Okay, so can we solve for it? How can we secure our secrets over here? Turns out there's another nifty tool in Google Cloud called Secret Manager, which you can use to manage your secrets. Okay, over there on the left, you can see a list of different secrets in the web console that I've injected into my project. And then if you click into any of these secrets, you can actually see multiple versions supported for that secret as well. So it's not just a secret manager or secret management tool, it's also some sort of version control, allowing you to maintain multiple versions of that secret. And this is something that's really powerful, because if let's say you are a vendor you're supporting multiple clients at once, and maybe some of them are running different versions, due to their own needs. You can actually allow them to use different versions of those configuration or secrets they've inputted here in Secret Manager. Okay, and when you have deprecated, certain versions, you upgraded them away, you can just look at destroying those secrets entirely. Leave no loose ends lying around. Okay, with this, we have added Secret Manager in. But as you can see over there, there's still that ... between the virtual machine and secret repository. So actually, I'm not entirely convinced yet that this is something that's secure for our systems. Okay, because there is one fundamental problem here. So that virtual machine over there has no identity. If that virtual machine, right, is like any computer connected to the internet, can talk to Secret Manager and pull the secrets, right? Then can't like any of your laptops or mobile phones can just go to My Secret Manager and take that secrets as well. Then that defeats the purpose of putting in a Secret Manager in the first place, right? So another thing we can use in Google Cloud to allow ourselves to do access control really easily is to use something that's called identity and access management. All right. So using identity and access management is actually really, really simple. You can just go to the web console, input, like let's say in this case, I've assigned, you can see over there, the top part principal, right? That refers to a service account or user account, which I want to assign some permissions to. Okay, so in Google Cloud, or in fact, in I think most cloud systems, right, you have this thing, two things called user account and service account. Okay, user accounts is like, the accounts that we all use as actual human beings. Service accounts are accounts that are used by these different processors or machines. Okay, it's used to represent an identity for them, in those machines that are running on. And over here, for that machine, I want them to have this identity so I can assign those permissions or roles to them. Okay, and over here, I've assigned the virtual machine. You can see in the center the role of Secret Manager Assessor. Okay, allowing the virtual machine to be able to grab those secrets as they're deploying my application. Okay, thus allowing only this virtual machine to be able to do that. All of your phones or of your laptop, you cannot touch my Secret Manager, or it's not exposed publicly. Okay, so this allows us to solve for the access control problem. Okay, all right. So you can see with that, we have securely drawn that one bow line between the virtual machine and Secret Manager. Okay, what other things can we add to this solution? How about making this solution fault tolerant? Okay, there are situations where, let's say Facebook can go down. And, if that situation happens, what it means is that my live stream will happen, but it will stream to nowhere. The destination itself is just dropping that stream. And after, let's say, Facebook recovers, or, any of these destinations recover, I essentially lost my entire stream. So what can I do over here to help me be more fault tolerant, in these scenarios? Okay, what if I'm able to create some sort of backup? If I'm creating this live stream directly, right, essentially I should have some sort of video file that I can create at the end of it, as part of this entire live stream. What if I can take this video file and back it up, using one of these cloud tools in Google Cloud today? Okay, so essentially you can use this other nifty tool called cloud storage to save, your files. It's an object storage solution. In this case, the Node backend server that we had earlier on, what I've done here is I've essentially written a piece of logic to detect, when the stream has ended, take this video file and move it to one of my cloud storage buckets. Okay, so by doing this, what it has securely allowed me to do is that at the end of every live stream, I would have a video file inside one of my storage buckets. So I can use these video files and maybe upload to Facebook or, YouTube later on if I need to, if let's say any of these different channels are compromised in some way. Okay, so with this, we have some sort of reliable, backup solution. Okay, and you can see over here, this is essentially part of a web console of the cloud storage. On the left-hand side, it's kind of like a directory structure. You can click into it and find where your video file is, depending on where you configure it to be uploaded at. Okay, and once you find the video file, essentially it's the same as clicking any other link on the internet. In this case, it's an MP4 file. I click the link, you open up a video player, in my web browser. Okay, so we almost have our whole solution here already. Okay, but looking at this, the more perceptive people within you may be asking the same question as I asked earlier on, which is, for the virtual machine, it was not easy to set it up, right? In terms of manually doing it. Wow, but I add so many things over here. That means I have to manually go and add all these things all over again, right? Is there an easier way to automate the setup for this entire infrastructure as well? not just for the virtual machine alone. Okay, so for those who are working in DevOps or related areas, you all might be familiar with this term, which is infrastructure as code. So instead of looking at your infrastructure as assets that you provision from the cloud providers, look at it as configuration or code that you can actually back up in your code repository. And when you do that, you essentially have something that you can see on the left, which is again another YAML file representing all of your assets that you're running in a single Google Cloud project. And what you can do here is essentially you can just put in all this configuration. For example, I need a virtual machine. I need this cloud storage to be set up. I just need to put in all these instructions within infrastructure as code configuration within Google Cloud to be able to do that. And in Google Cloud, the tool for infrastructure as code is Deployment Manager. Okay, so you can use this to be able to quickly deploy your solutions to Google Cloud very quickly instead of manually setting up, just now the IAM as you saw on the screen, as well as setting up the cloud storage, cloud build, all that. All I need is one single click of a button and everything is set up. Okay, but truth be told, Deployment Manager is not perfect. There's still some things that are not covered for by that. So very simply, I can just also add a wrapping shell script to just cover for the remaining items that I cannot provision using Deployment Manager. Okay, so running one single shell script, okay, and I'll be able to get like this web console as you see over here, where if you set for Deployment Manager to do it in preview mode, you actually get to see like all the assets you want to bring up in Google Cloud before you actually do the actual deployment. This is where before you actually pay the money, because here they actually haven't done it yet. Okay, so if I click the deploy button, essentially what happens is that in a few single clicks, right, for example, running that shell script and then clicking that preview button or that deploy button, essentially I'll be able to bring up everything all at once. So it has shortened my entire bring up time, right? From like a few hours of setting up everything in a Google Cloud project to less than 5 minutes today, thus allowing us to simplify our entire bring up of our application here. Okay, so this is where the fun part will begin. Okay, so I'm going to go over there. I'm not sure if someone's going to turn the camera. But yeah, this is where we're going to do a fun part, which is we're going to use this actual streaming application, and I'm going to be streaming all of you. So you're going to be my live talents who are going to be going onto my YouTube channel as well as my Facebook page. And I need you all to cooperate with me to do this because we're going to be going on the internet. And I need all of you. I'm going to do a countdown later, so it's going to go something like this: 3, 2, 1. And I need you all to say yes as loud as possible, okay, for 1 to 2 seconds, and then just cheer as loud as possible after that. Okay, so can I get all of your help to do that? Okay, so let's do a rehearsal first. Okay, I'm gonna do it right now. Okay, this is gonna be very fun, man. Okay, 3, 2, 1. Yes! Wow. Thanks, man. Okay, let's try the demo now. Okay, give me a moment now. Yes. Okay, I'm gonna give us a few minutes. Okay, so maybe I'll just introduce a little bit of what's going on here. So we're going to be using StreamYard as you see in the screen over here. Okay, what's going to happen is that I'm going to stream actually using my phone, not using the laptop's what do you call it, camera. Okay, I need more hands. I'm going to use this. Okay, hopefully y'all can hear me. Okay. Ooh, upside down. Ooh. Okay, I guess this works. It's not live yet. Just letting you know, it's not live yet. It will go live. I'm going to now actually start some of the stream. Hold on. Okay. I know it's going to be a bit counterintuitive, but I'm clicking this go live button. It's not live yet, so don't worry about it. I'll give the countdown in a bit. Okay. So what's happening right now, you all can't see on the screen, but what's happening now right now is I'm just checking on YouTube and Facebook just to make sure that the stream is sending properly over there before we actually run this entire demo slash experiment. Oh, okay. So Facebook is up already. I'm just waiting for Google. Oh, okay. Yeah, YouTube is up as well. Okay, so all of you ready? I'm going to start it already. Then I'm going to do a countdown already. Okay. All right, okay. Okay, so we're going to do a countdown. We're going to do it now. 3, 2, 1. Yes! Okay, so what's going to happen here is I'm just going to end all the live streaming so that we don't do any more weird stuff on the internet. Okay, let's end it. And okay, yay, we managed to get everything on the internet. So, okay, somehow autoplay happens. Give me a moment. Let me unplug this for a bit. Sorry, sometimes there's this thing, right, for presenters when they do these presentations, right? There's this thing called demo god. So sometimes doesn't bless us, then this type of things happen. Is he there? Oh, never mind. Well, let's take a look at the video to see what. Yeah, so this is essentially what happened. This is not DevSpace YouTube account. This is my own YouTube account. So yeah, wait, need to turn on sound just to show you all that it actually works. No sound. Okay, so we're gonna do a countdown. We're going to do it now. 3, 2, 1. Yeah. So yeah, I think it's a little bit blown up, right? Let's zoom out a little bit. I think some of you might have caught the joke just now already. So yeah. I'm sure if y'all can see. Thanks, Okay, so okay, enough looking at myself. Scamming people to say that I'm handsome. Okay, let me go back to. Okay, so thanks for humoring me in doing this demo. So hopefully let's look at some of the quote-unquote learning points. Okay, if y'all want to go to those pages just to see the videos later on, y'all can just scan this very quickly. I'm gonna give like 5 seconds for whoever wants to do it. 5, 4, 3, 2, 1. Oop, I can see it. Okay, I'm gonna wait for a bit because I can see some people are scanning. Just to show y'all like this is real. I didn't like fake this. Okay, I see no more cameras. Okay, I can see some more. Okay, maybe later I'll share the QR code again. Okay, so let me go to the next slide. Yeah, so just want to jump a little bit back into our solution. Because of course, one of the things that I didn't really talk about is like just now of the three conditions we want to solve, right? Easy to use, okay, StreamYard solved that. We want it to be able to stream to multiple destinations. I think with the earlier demo, you all can go to the Facebook page or the YouTube channel, it's both there. Okay. The last thing is cost. Did we actually achieve a low cost as we anticipated? And yeah, we did that. So you can see over there that we actually held live streams at different timings. You can see that those what do you call it? The when the graph goes up, right? At this certain splits, right? You actually see that those are actually timings where we are provisioning some resources on Google Cloud. Okay, so towards the end, we actually perfected the use of the application itself, allowing us to only pay around 76 USD per 2 to 3 hours live stream. Okay, so in a month where we were running like 2 live streams, that's like maybe $2, which is much less than the subscription increase, which is like I think around $30 to $40. So very much able to meet the low cost as we wanted to. Okay, and rounding up our entire solution, so we were able to build this end-to-end solution encompassing all these different tools that you see on the screen. I believe this is like 10 different things, right? But the sky's the limit. There's much more that you can build in Google Cloud. Okay, as I mentioned earlier on, Google Cloud is not just for you to host your applications, your web applications. You can do more with it if you want. For example, cloud monitoring. They have monitoring tools built in, allowing you to build your own dashboards, integrating with your own alerting systems like to PagerDuty. You can put in respondents. If something goes wrong, you can alert you right away. There's also things that you can input in like speech to text API. For example, just now I mentioned about that fallback video file, right? The MP4 file. What if I take the MP4 file and put it through this speech to text API and get a bunch of captions? That's essentially subtitles, right? So I can do something like that with Google Cloud as well. So like I said, the sky's the limit. You can check out the different tools in Google Cloud and find out, what unique features you can build. Or if you have something you want to build, you can try and find out what tools are there in Google Cloud to solve for your own needs. Okay, so what do we learn? We were able to build a very complex solution easy with Google Cloud. Okay, and also bringing it up really, really quickly by automating, a big part of our process. The next part, okay, I guess the joke didn't really go off well, but yeah, scammed everyone to say I'm handsome. So yeah, thanks. Okay, so the next case study is just a very short one. It's just more in terms of sharing with you all, like if let's say you are a student going for hackathon or you're just doing a side project over a weekend, this is maybe something that might be more relevant to what you might be looking at in terms of creating a simple web application with a database, creating some POC of a product that you want. Okay, so yeah, a simpler problem that you can use as a baseline for creating your own solutions. Okay, so this essentially, I'm just going to bring up like the entire problem statement itself was that I'm working with a professor in NUS and we wanted to host this application, like the code is already written there. It's an open source conference submission tool. But what we wanted to do is we wanted to host this in Google Cloud. And then you also had some database requirements. So we wanted to use some managed database solution in Google Cloud as well. Okay, so we knew that, okay, we need some sort of hosting solution. We knew that we need some database. And maybe, we want to make the process better for ourselves. Maybe we want to containerize it. Again, like earlier on, using Docker images. Okay, so I'm going to use like the same format as earlier on, showing you a very high level of image of our entire solution. All right, hosting solution, again, the same question as we asked just now. But in this case, what we realized was that we didn't need that level of customizability. We just want to be able to bring up this application and be able to easily maintain it and scale it up as easily as we want it to. Okay, so it's a very easy decision. Go with Cloud Run or go with App Engine, any of these two choices. Okay, so I'm going to replace the center point with Cloud Run. And then also, of course, we wanted to be able to, like for Cloud Run, you actually have image dependency. You need to create your own Docker images and host it on Cloud Run. So of course, you need to save the image somewhere. Okay, in this case, we're using artifact registry. Okay, just now I was using container registry for the earlier solution. Like I said, there's multiple solutions that you can use. In this case, I tried out with artifact registry. For the purpose of hosting images, it's almost exactly the same. And then also access control. Earlier on in the complex problem, we also had some access control issues, right? In this case, my Cloud Run needs to save, like let's say the database password. Where do I save it? And how do I only allow Cloud Run to be able to access those secrets? Okay, so some sort of IAM, identity access management, as mentioned earlier on, and also adding in the secrets as I mentioned. And then lastly, is just replacing a database In my case of this simplified example, right, it just needs a relational database, MySQL. Okay, so there's already a managed tool today in Google Cloud that supports that, which is Cloud SQL, as you see on the bottom there. So you don't have to get your own virtual machine and run your MySQL instance on it. Don't do that. Okay, it's already supported for in Google Cloud. Just use it directly from there. And yeah, with that, I was done with building that application very, very quickly. We were able to host that web application via Cloud Run. The left side is the web console. The right side is how the application actually looks like. So it's an open source code. Like, I didn't really design the front end. It looks a bit like 2000s website, but yeah, I mean, it is what it is. It's just for hosting, collecting conference submissions. But I think the most interesting part was how fast I actually, how little time I took, right, to actually build this entire thing up. Like, just the cloud deployment portion, right, took 3 hours of this entire 12 hours I sink in over the weekend on this one single problem, which is, like I said, I already have the code base, so I'm not building it from scratch, but I'm just looking at how I can bring it up into the cloud, okay? And in total, that only costs 25% of that entire 12 hours. Of course, I would admit that, with my own knowledge in Google Cloud, maybe it was a lot easier to go in and do it. But rest assured, as you use Google Cloud, a lot of these tools I've shared over there is very, very intuitive to use. Okay, so you should be able to, through the web console, you don't need to think about those automation optimizations early first. Think about, just going to web console, see how you can provision all these tools, very quickly, test it out first. Once you get that solution, then you think about optimizing it further. Okay, so we were able to reach that, early POC stage, right, very quickly in just 3 hours spending on Google Cloud. And then, of course, I just want to show a bit of building. In this case, actually, this was actually even more costly than the complex solution because there's a database requirement. Unfortunately, you have to pay for it. But the really cool thing here is, actually, I don't want to bring your focus to here, but rather, to the next screen, actually, which is this one, which is that in Google Cloud, there's actually a lot of free quotas for you to use. You can check out this link. But the idea is that, even for myself as a student, I was able to leverage off a lot of these free quotas and build my own personal site for free. Back then, I think App Engine was running at free 27 free instance hours a day. Now I think it's 28 now. But what it means is that if it's more than 24 hours, right, that means you can run one free instance for 24 hours and then run another second instance for 4 hours if you want to. But I mean, you can choose not to do that and just run your own web application for 24 hours straight. Or you can use Cloud Run. I believe it services like 2 million free requests every month. But that's the strength of using Google Cloud, which is, that free quota allowing you, before sinking in your own money, you're able to actually just test out part of, the tools that they provide and allowing you to have that very quick POC, as long as it's not in production yet. Because a lot of this, the moment you share with other people, like let's say, you product launch, of course, you'll get a lot more traffic. You'll go beyond that free quota. So just make sure you test within your own area first, like make sure you're comfortable first before you allowing yourself to make that more informed decision before putting your money in. Again, the joke didn't went well, but I guess this is the Q&A part.
Thank you. It was fun and it's good demo. So in streaming, right, based on my experience, the most important thing is, correct me if I'm wrong, okay? First thing is bandwidth cost, right? Another thing is transcoding. So when we're talking about, so you are saying that you will be broken into multiple those big players, YouTube, Facebook. You are expecting a lot of audience, maybe like 100K or million audience, right?
Not that much, but it was more like local communities.
So theoretically, so now you show us the bill, and then you said the StreamYard adding more, more destination is expensive than relaying from Google Cloud Engine, right? So there was no cost for bandwidth. So if you have a lot of audience, how much will it be? I mean, is it true if it's affordable compared to streaming directly from StreamYard or relaying through the Google Cloud Engine? That would be cost of the bandwidth, right? So that is the one question. Another thing is that what about the transcoding? So when you talk about reaching to a lot of end user, right? So you transcode into different quality, and then you you need to deliver based on the audience bandwidth. So, but the thing is, you are not getting the audience the bandwidth directly to your stream app because you have this Google Cloud Engine in between as a middleman, right? So that means the bandwidth is always consistent. So when you stream and deliver this quality of the video, it will be always be consistent, and it won't match to the actual audience bandwidth. So how do you solve these issues? Thank you.
Thanks for the question. So yeah, maybe I'll repeat the question first before answering them. I think the first question is in relation to bandwidth cost. And I have a very cheap answer to this, which is that I didn't solve it. I let other people solve it for me. Which is that if you look at it, right, actually, okay, let me go backwards and many slides. No, actually, it would be faster if I just go to, okay, you know what, let's just do this. Okay, yeah, we get here already. So if you see over here, okay, the thing is the network, like bandwidth cost, right, all ends up at the end, right, where the users are viewing your stream, right? That's the question that was asked. And the issue is that because all I'm doing, right, is just relaying the stream from StreamYard over to those destinations. And because I'm using all this for free, right, I'm not paying the cost myself. I'm letting them do the solving of that problem themselves. Of course, for them, they're in the business of allowing us to do this live stream, right? Of course, they will have their own business models in terms of how that would work out in terms of cost for them. So to that question, yeah, I know it's a bit of a cheap answer, but I really didn't solve it for that part. The second question is, sorry, can you repeat the second question again?
So from here, right, from RTMP stream, from StreamYard, the stream transcoded video stream, right, to your NGX RTMP module. I believe you are using the RTMP bit module of the NGX Enterprise Edition, right? So there is this connection from the stream app to your server. So that network is consistent, right? Because you have only one bandwidth, a consistent bandwidth between this channel, right? But the thing is, you are relaying your streaming from your engine server to actual audience. So actual audience, they are watching your stream on YouTube or Facebook or Twitch TV, right? So let's say I'm watching on my phone, and my bandwidth is I'm on 3G. My bandwidth is very low, and you the channel between your RTMP StreamYard and the engine server is like maybe a 400 megabyte per second. Bandwidth is consistent. Now maybe StreamYard is transmitting this high definition 1080p. But then the thing is, as the audience, I'm on my phone, I'm on 3G, and I cannot load it. Because
but this is the thing, the destinations here are the ones that take care of it. Like all I'm doing is, so this is a custom functionality in, like let's say in Facebook, in YouTube as well, where I'm just streaming, like as a custom RTMP server, I'm just pushing this stream to them. So for the viewers, right, on let's say in the YouTube channel, they're just viewing the video via, like let's say the source of that stream is through YouTube. So they do the processing of it, the network bandwidth cost is on them, transcoding as well. Like, you know, if there is a need to move at different levels, right, quality, right, that's on them as well. But so all I'm doing is I'm just relaying it across.
Yeah, but the media source is from your server, right? So when I watch from your Twitch TV channel or YouTube channel, it is pointing back to your server, the actual source, right? Because you are doing live streaming.
Correct.
So that means all the traffic route to your server.
No, the traffic is at the level of, let's say, the YouTube channel or the Facebook page, because I'm just passing that stream over to these destinations. Yeah. So if when you're viewing it, you're viewing on their, like let's say the YouTube channel, right, or their pages, right? That stream comes from their domain, not from my domain.
Yeah, their domain, yeah, but they need to point back to your server, right?
No.
They don't need to.
Don't need to.
So it's not live streaming. You're passing the physical file.
No, it is live streaming, but I mean, live streaming in the sense that I'm doing it at that point. That feed is going over. I can view the comments at the point of time and react to it.
Right, the data transfer live, real time. So if they don't point back to your server, how can you say it's live streaming? How can you transmit the data, the streaming data, to YouTube and Facebook?
No, I am sending the stream over to those pages. But you're asking in terms of the bandwidth cost, like for the users, are they streaming directly?
Bandwidth cost is one thing. Another thing is different user on different network, different bandwidth, right? Different speed, different internet speed. So let's say my phone I'm on 3G, for example, and I cannot load on my screen, I cannot see this high definition media. So maybe I may be able to see this, play this video, the live stream video, just real. If you can transmit that data, smaller size, which is maybe 480p, right? So how do you adjust between different quality based on the audience with this approach?
No, again, this is not controlled my end. All I'm doing is just relaying that stream forward. And then the quality is controlled on their end.
Okay.
Maybe we
Thank
catch
you,
up
thank
later
you.
on.
Yeah, we're going to talk
Yeah.
later.
Yeah, thank you. Another question about these two solutions. The first one, you choose a computer engine, which is a virtual machine. The second one, you are using a cloud run, right? It's a container based. But both of them, you are running a container inside. Could you explain more about why you choose one rather than the other? I mean, the first one, you're using virtual machine. Second one, using cloud run. But they all running a container inside.
Yeah.
Yeah. So can you switch it, or is it?
You can.
Okay.
Oh, sorry. I take it back. For the second one, you can use compute engine. Yes. For the first one, I can't use serverless because unfortunately they don't support RTMP at this point of time.
Oh, is it because just the protocol or just TCP?
Just the protocol, yeah.
Oh, TCP connection, is it?
Yeah.
Okay, got it. Thank you.
Sorry? The node server.
Functionality of the node that you used earlier.
This one. So yeah, the question over here is just now I mentioned that I was going to explain like what the node server was about. This one was that node server was essentially to detect that video stream when it ended, take that video file and push it to cloud storage. Yeah.